Good morning. I am Dr. A. Kalaiselvi. Today I present the topic Constraint Satisfaction Problem. In a constraint satisfaction problem, the goal is to discover some problem state that satisfies given set of constraints. Basic workflow of constraint satisfaction problem is we need to analyze the problem perfectly. We need to derive the constraint given in the problem. Then we need to derive a solution from a given constraint. Find whether we have reached the goal state. If we have not reached the goal state, we need to make a guess, and that guess has to be added as the new constraint. After adding new constraint, again we go for the evaluation of the solution. Now we need to solve the problem by using this added new constraint. Again we have to check whether we have reached the goal state. If yes, solution is found. The algorithm for constraint satisfaction problem is first propagate available constraint. To do this, first set open to the set of all objects that must have values assigned to them in a complete solution. Then do until a inconsistency is detected or until open is empty. That is, in a subselection, select an object OB from open. Strengthen as much as possible the set of constraints that apply to OB. Next, if this is different from the set that was assigned the last time OB was examined, or if this is the first time OB has been examined, then add to open all objects that share any constraint with OB. That is, OB is the objects in open. Then the next step is remove OB from open. If the union of constraint discovered above defines a solution, then quiet and report the solution. That is, the constraint discoveries defines a solution. That is, for solution found means then quiet and report the solution. This is the final solution. If the solution of constraint discovers the above defines a contradiction, then returns failures. If neither of the above occurs, then it is necessary to make a guess at some time in order to proceed. To do this, loop until a solution found or all possible solutions have been eliminated. That is, next, select an object whose value is not yet determined and select a way of strengthening and constraint on this object. Then recursively invoke constraint satisfaction with the current set of constraint augmented by the strengthening constraints just selected. One example of algorithm working. Consider the crypto arithmetic problem showing in the below figure. That is, problem is cent plus more is equal to money. Assign the decimal digit to each of the letters in such a way that the answer to the problem is correct to the same letter occurs more than once. It must be assigned the same digit each time. No two different letters may be assigned the same digit. Consider the crypt arithmetic problem. The constraints are no two digit can be assigned to same letter. Only single digit number can be assigned to a letter. No two letters can be assigned the same digit. Assumptions can be made at various levels such that they do not contradict each other. The problem can be decomposed into secured constraint. A constraint satisfaction approach may be used. Any of such technique may be used. Backtracking may be performed as applicable as applied search techniques. Rule of arithmetic may be followed. That is initial state of problem. Find the value of D, E, Y, N, R, O, S, M, C1 and C2. C1, C2, C3 stands for carry variables respectively. In the goal state, the digit to the letters must be assigned in such a manner so that the sum is satisfied. The solution process proceeds in cycles. At each cycle, two important things are done. Constraints are propagated by using rules that corresponds to the properties of arithmetic. A value is guessed for some letters whose value is not determined. This is the flowchart for this. The explanation is then followed. That is, the rule propagation constraints generate the following additional constraints. That is, m is equal to 1. Since two single digit number plus a carry cannot total more than 19. Therefore, s is equal to 8 or 9. Since s plus m plus c3 greater than 9. And m is equal to 1. S plus 1 plus C3 greater than 9. So S plus C3 greater than 8 and C3 is at most 1. C3 is the carry. Carry is at most 1. Then O is equal to 0 since S plus M of 1 plus C3 is less than or equal to 1. It must be at least 10 to carry 10 to generate a carry, and it can be at most 11, but m is already 1, so O must be 0. The same value cannot be repeated. Therefore, O must be 0. N is equal to E or E plus 1 depending on the value of C2, but n cannot have the same value as E. So, n is equal to E plus 1 and C2 is 1. In order for C2 to be 1, the sum of n plus r plus E1 must be greater than 8. Therefore, n plus r cannot be greater than 18. Even with a carry in, so E cannot be 9. Assume that no more constraint can be generated. To progress at this point, guessing happens. That is, if E is assigned the value 2, now the next cycle begins. Constraint propagator shows that n equal to 3 since n is equal to E plus 1. Therefore, R is equal to 8 or 9 since R plus n plus E1 equal to 2 or 12, but since n is already 3, the sum of these non-negative numbers cannot be less than 3. Therefore, R is equal to either 8 or 9. Then 2 plus D is equal to Y, or 2 plus D is equal to 10 plus Y from the sum, the rightmost column. Assume no more constraint generator, then guess is recorded. Suppose C1 is chosen to guess a value for 1. Then we reach dead end as is shown in the figure. When this happens, the process will be backtrack. That is, previously C1 equal to 0. Algorithm for constraint satisfaction, in which chronological backtracking is used when the guessing leads to an inconsistent set of constraints. So that is, constraints are generated or left alone if they are independent of the problem and its cause. Therefore, this approach is called dependency directed. Thank you.